us dive into power factor basics. Power factor, if you have done electrical engineering or maybe even electrical and computer engineering or even maybe computer engineering or mechatronics, it is a concept that is integral. That is a key cornerstone knowledge piece for single phase circuits, three phase circuits, right? AC systems, basically. Okay. Now, when we are dealing with power factor, we can take a multitude of different approaches. We can look at it strictly from the standpoint of our equation. We can memorize that power factor is the ratio of your real power in kilowatts or watts divided by your apparent power in VA or kVA. And while we are at it, also memorize that power factor is equal to cosine theta, right? A lot of people, when they first are introduced to this concept, limit their understanding just to the mathematical equation. They expect that they're going to be given real power, right? And apparent power, and they would just have to find the ratio of the two, and that would basically give them power factor. That's where I started out as well when I was first initially exposed to power factor. But there's a lot more to power factor. It's actually a very deep and abstract concept, um, quite elegant if you want to really thoroughly understand it. Okay, so we are going to go through power factor through three different lenses. This is how I basically explain it to my students who are in my FE electrical program and the P power program, because connecting the dots is what really reinforces understanding, right? From a neurological standpoint as well, they say neurons that fire together, wire together. Okay, and that's why there is so much emphasis on uh, repetition and practice. Okay, but it should be meaningful practice, not just doing the same thing over and over again doesn't necessarily help. Okay, so the one way of looking at it is from the standpoint of oscilloscope. So let us say that I have a voltmeter and I have an ammeter. I have an oscilloscope, the leads going out, right? Real time monitoring the voltage and real time monitoring the current. So the oscilloscope may show that the peak of your voltage waveform is appearing first, followed by the peak of the current waveform. Okay, this is very intuitive. Anybody who has done very basic lab work for circuit analysis, electronics, and your power undergraduate classes, you probably have seen something like this, right? The idea over here is that on your x-axis, you basically have degrees, right? You have degrees, and then you can see that the angle difference between these two is what goes in this formula, okay? The argument of this formula, cosine of which angle? Of the power factor angle. And how can you find that power factor angle? By looking at the delta, the phase difference between the voltage waveform, one point. So pick any point, whether it's the starting point of this waveform, starting point of this waveform, or whether it's the peak of this waveform and the peak of this waveform. So select one point and do a delta. So that's how you extract it. And you can also have a current that is leading the voltage, right? And we're going to talk about leading and lagging power factors in a bit. They're very important to understand. The other way to look at it is by means of your power triangle. Those of you who are preparing for the FE electrical, in the reference handbook, they mentioned the power triangle. Those of you who are preparing for the P power, in the reference handbook for P power, you're going to see that, right? So what is a power triangle? The power triangle, remember I told you that this equation involves kVA in the denominator. So the kVA apparent power in absolute sense is basically the magnitude of your complex power, right? So if I look at this complex power as, okay, as a polar or as a complex number, it is basically equal to P plus JQ, right? So complex math 101, you have Z is equal to R plus JX. And similarly, you have any complex number, let's call it U is equal to A plus BJ. Okay, makes sense? So when I do a cosine on this guy, okay, S cosine theta, where S is the magnitude, that basically gives me this component. Okay, so this apparent power is the magnitude of my complex power. S cosine theta gives me its shadow, its projection on the x-axis. Okay, and this theta that you see over here is theta power factor. All right. And as far as the y component is concerned, because j is on the y-axis, remember, in the over here, b is on the y-axis, right? The b component. So for this, I can simply express this as q is equal to s times sine theta. Okay, and we can go into trigonometry in details and whatnot if you like, but at the very least, I would like you to understand what the makeup and composition, what the ingredients of this power triangle are. Because this forms a foundation of a thorough understanding of leading and lagging power factor. And leading and lagging power factor impacts the phase angle, power factor angle. And proper usage of power factor angle is going to either result in a point on the exam if they test you on leading lagging, which honestly, if I'm setting the exam, I would definitely throw in that curveball, because just this equation, maybe for your first year engineering or maybe at high school level, I would say that's probably plug and chug, very simple, straightforward. But anybody who pretends to know power factor should be tested on something like this. Okay. And the third and the final lens through which we are going to look at power factor is based on the impedance, based on the load, based on the composition of the load. How much real component we have in the load and how much imaginary component we have in the load. If you're new to this channel, please consider subscribing. On a weekly basis, I'm creating content for FE electrical and PE power exam preparation. I also discuss topics related to electrical engineering with a focus on power systems engineering. If you'd like to learn more about my FE electrical and PE power exam preparation programs, please visit my website, studyforfe.com.